7 o'clock. We're going to get started. Welcome, everybody, and thank you so much for joining us. We know that these are trying times, and you are going in a million different directions, and we really appreciate you spending some time with us this evening. This is the fourth and last in a series of webinars we've been doing that are grade specific. This one is for grades 9-12. Over the past few weeks around the topic of integrating digital media into your science curriculum. This is all drawn from a collection of resources that live on PBS LearningMedia, and the collection title is called Bringing the Universe to America's Classrooms. So we had webinars for grades 6-8, 3-5, and K2. And you'll have the links to those recordings if you'd like later on in the program. I'm Carolyn Jacobs at GBH Education, and I'm very happy to have you with us tonight. The session is sponsored by GBH, which is Boston's PBS station and the producer of many of the programs that you see on your local public media station, like Nova, for example, American Experience, Frontline, etc., and lots of kids programs. And we're also sponsored this evening by PBS LearningMedia. I mentioned that right in my little intro, that this is where the collection of resources live that you're going to see a lot of this evening. But in addition to Bringing the Universe to America's Classrooms resources, there are thousands of resources on this free site for K-12 across the whole curriculum, but we're very strong in science. So if you haven't already, we encourage you to check out the site and explore on your own. Our main presenter this evening is Sean Stevens, who's the Director of Curriculum, STEM Curriculum and Instruction at GBH Education. And she is joined by another Sean, different spelling, Sean O'Brien, who's been teaching for about 6 years. He teaches in Pennsylvania. He's a Penn State grad. And Sean teaches AP Biology and Earth and Space Science. And our other teacher presenter, wonderful, is Eric Fleming from sunny Arizona. And Eric teaches geology and other physical sciences in high school also. And both gentlemen have been teacher advisors with us, working as part of cohorts, helping us produce to make sure that these resources that we produce are really what teachers need. And so they've acted in an advisory capacity, and we appreciate that. The agenda tonight is Sean Stevens is going to kick things off, talk a little bit about the collection as a whole of resources, and then showcase particular resources. Many of them are brand new. So if you are familiar with the site or the collection that we're talking about tonight, continue to visit it because we are publishing new resources all the time. After Sean, both Sean O'Brien and Eric Fleming will give us examples of how they use the resources with their students, and then I'll come back on for a few closing remarks. A couple of housekeeping notes in the chat. We want to make sure that you can set things to speak to both the presenters or panelists and attendees. So if you post a question or a comment, I'm not sure what your default setting would be, but we'd like you to be able to share that with both the panelists and the attendees if you're able to. And then a lot of people would like to have a copy of the chat. And there are 3 dots that if you click on, you can click Save Chat, and on my computer, it saves to my Documents folder. So it will live somewhere on your computer. We welcome questions and comments in the chat. Everyone will be active in it when they're not speaking. And if you do not get your question answered, we'll try and get back to you individually after the fact. We are recording this evening, and you will receive a recording link along with other links in a follow-up email tomorrow. And at the very end of the program, you'll have a link to a survey. The survey really helps us do a better job. And at the end of taking the brief survey, you will, you can download a certificate of completion to acknowledge that you participated this evening. Angelica from our team is in the chat. She's helping us out post links so you can keep up with what we're talking about. We're going to end on time at 45 minutes, 15 minutes before the hour. And I'm going to turn things over to Sean now. Thank you.
Okay, thanks, Carolyn. And I just wanted to remind everybody that you will get a link to all the resources that we're talking about tonight. And Angelica's already put the link to that document up on the webs or on the in the chat, so you can follow along with us if you would find that useful. So first, I'm going to start off just telling you a little bit about the project that is behind all these resources and this collection on PBS LearningMedia. As Carolyn mentioned, the name is Bringing the Universe to America's Classrooms. And it's the resource development was done in collaboration with NASA and its affiliated organizations, as well as teacher advisors across the country, two of which you're going to be hearing from tonight. These resources are designed to help kids from kindergarten through 12th grade meet important earth, space, and physical science learning goals. They're not a curriculum or full-blown units, but supplementary resources. So they're designed to be flexible and adaptable and to be used in multiple ways in multiple curricula. Next slide, please. Just to give you a little idea of what's in the collection, this here is our home page. And you can see that the resources are organized by grade band. And then within each grade band, there are sub-collections organized by topic. For a high school, in addition to the 4 listed there, waves, space, earth systems, and weather and climate, there's also a collection for history of Earth. And all of these sub-collections contain sets of resources that are aligned with NGSS disciplinary core ideas and help engage students in science practices. Next slide, please. So within the collection, there are several types of resources. The ones you're most familiar with, I'm sure, are lesson plans. And for these, they provide examples for how you can use, integrate media from the collection into a coherent learning experience where students can work towards a learning goal. For interactive lessons, those are also arranged around a learning goal, but there's sets of media organized for students to work through independently at their own pace. To go along with the media, there's text and, to help them interpret it and conceptualize the ideas, as well as learning tasks and formative assessments along the way. In addition to these more extensive learning experiences, we have resources that contain videos, images, models and simulations, and other types of visualizations to help your students engage with phenomena and in practices. Next slide, please. Even though the resources are supplementary, that doesn't mean that they don't come with any supports. Because this is funded by NASA, it's a 508 compliant. And so that means we have a lot of accessibility features. All of the student handouts and interactive lessons are screen reader compatible. All the images have image descriptions, and all of the videos are closed captions. There's also a lot of videos that have descriptive video as well. We're in the process of translating all of the student-facing resources, that would be media and student handouts, into Spanish. And if you look at that, see that little yellow badge up there that says Excuse me. Also in ES, that indicates that the resource is also available in Spanish. And that isn't just within this collection, but throughout all of PBS LearningMedia. There are also support materials for teachers and students. There's background about the media, as well as the content that's needed to interpret it. There is tips to help give ideas for how you might integrate it into your curriculum, ideas for discussion questions. Often there are handouts for students. And then with the lesson plans, we also have supports designed for English learners, as well as non-visual supports, which often provide alternative activities if you need those. Something that teachers always ask about is how can we assign these resources? You can assign them through PBS LearningMedia, but you can also assign them through Google Classroom, Canvas, Seesaw, Schoology, Nearpod. Every time I look, the list gets longer. So Angelica will be posting a link to the page that tells you how and how to use it with various kinds of software, so you can check and see whether the software you use is compatible. Next slide, please. So when you think about digital media in the classroom, so often it's kind of a passive experience where some expert, often talking way too fast, just explains something about a phenomenon. We didn't want our digital resources to be that way. We wanted students to be actively engaged in it. So we really worked to make phenomena and data accessible in new ways so students could make observations and look for evidence that they can use to support claims and collect and interpret their own data. Next slide, please. So really what it comes down to is we wanted to provide opportunities for students to figure stuff out, not just explain things to them. So this is really consistent with NGSS. Next slide, please. So now I'm going to just kind of dig into some individual resources in the collection. This year, we were working a lot on Earth systems. And one of the major ideas within this is that Earth systems are dynamic and interact with each other. This first resource, Earth, a System of Systems, focuses primarily on the dynamic nature of the four spheres and provides one or two examples of that illustrate this dynamic nature. For lithosphere, we have volcanic activity and the birth of an island. In the hydrosphere, both ice flow and differences and changes in river discharge around the globe. Next slide, please. For the atmosphere, we have beautiful visualizations from NASA's SVS for that track dust and aerosol movement around the globe. And then finally in biosphere, we have a visualization that shows the changes in photosynthetic activity. So you can see where that happens, especially in the ocean, and how it changes, and the locations of these blooms. Next slide, please. So to get more at the interaction, the spheres interacting, we developed a set of resources on the relationship between atmospheric carbon dioxide and photosynthetic activity. Carolyn, would you please play the video? Thanks. So this again is a visualization from NASA's SVS, or that's Science Visualization Studio. And the yellow is, represents the concentration of carbon dioxide, and the green and the land is just the greening and the vegetation coming and going. And so by going through a couple of years of this tracking, you can start to see how this kind of dynamic relationship between the plants and carbon dioxide levels, especially in the Northern Hemisphere. Thanks, Carolyn, you can stop now. So besides the set of media, very soon we will have a lesson plan published that includes not only this data, but other data that students can use to investigate the differing amounts of photosynthetic activity on land versus the ocean and how that affects the CO2 levels. Next slide, please. So the other major idea that we tackled in Earth systems this year was the role of feedback in Earth systems. So this is kind of a tricky idea. We have an interactive lesson that just focuses on the basics of what a feedback loop is and provides an example of positive and negative feedback. In this case, it's the ice albedo effect. The more ice that melts, the less sun's radiation is reflected. So then the more the Earth heats and the more the ice melts. Next slide, please. If you want to dig in even further into feedback, we have another resource that has a set of examples where students can dig in a little bit more actually into the example and think about the feedback, the processes behind the feedback. And we have several examples for both the balanced negative feedback and reinforcing or positive feedback. Next slide, please. Another new resource that we have is, it's filed under middle school, but I know a lot of standards have the carbon cycle at the high school level, so I'm just going to tell you a little bit about it. And I encourage you to look at middle school as well as high school, because sometimes it's nice to have either to support prior knowledge or trigger, or things are just, you know, different states have different needs at different levels. So this is a data layering tool, and it's for the global carbon cycle. And besides addressing all of the carbon reservoirs, one of the layers is represents the organic portion of the carbon cycle, and the other, the inorganic, which is actually often neglected, but really important, especially from a geological perspective. Next slide, please. In this resource, students can click on hotspots that to get more information on the processes within the cycle. Next slide, please. And within these hotspots, they'll have media and text to get more information. Perhaps more interesting to you all than this one is another one that we have in production on the electromagnetic spectrum. And in that case, the layers will be the different types of radiation in your daily life, and then uses to detect astronomical phenomena. Next slide, please. This is a resource that students can use to investigate patterns and relationships among volcanoes, earthquakes, and plate boundaries that was developed by the Concord Consortium. Carolyn, could you please play the video? Students have a lot of control over what you can look at here. These are the plate boundaries. The different types are color-coded. You can see the directions and the relative speeds that the plates are moving. When you look at the earthquakes and volcanoes, you have control over the time span that of the data that you're looking at. So here we're looking at the last decade. And the size of the spot indicates the magnitude, and then the color is the depth of the earthquake occurred. And then you can do the same sort of thing for the volcanoes and get data, and they can be overlaid in any combination that you want. It also has a kind of cool modeling tool where you can take a 3D slice of the a region that has a lot of earthquakes, and then you can see where the depth of the earthquakes occurred. Next slide, please. Excuse me. This next resource explores its evidence for the history of early Earth. This is a really difficult topic to address because it tends to be just kind of a story of what happens. And so we wanted to give students the opportunity to not only be able to track the events along the timeline, but you can see there's also matching that, or in parallel, they can track the evidence. And so they can sort of start to get a feel for how scientists are piecing this puzzle together to tell the story of what happened so long ago. Next slide, please. So when you click on any point in the timeline, piece of media will come up where that text that it describes the evidence and what it tells us about the Earth story. Next slide, please. And then you can click on the image and zoom in to get an even better look at what's at the evidence there. Next slide, please. Excuse me. So now we're just going to go into space, a totally new topic. And this is a resource that was developed in collaboration with Worldwide Telescope ambassadors at Harvard and NASA's Universe of Learning. Worldwide Telescope is kind of a repository for astronomical data. So all the data in the resources related, developed by them, it's real data. It's the kind of data that scientists use as well. That's just, we developed a simpler student-friendly interface to use it. This resource I'm going to tell you about is about the history of the universe, where students can work to calculate the Hubble constant. Can you play the video, please? So this is the starting page up at the upper left-hand corner. That is a map of the observed universe, the pink. The blue dots are individual galaxies that students can choose to visit and explore, or investigate. So the circled one is the one that they're supposed to study. They'll zoom in and use the approximation of size to estimate the distance. They can go in and see spectral data, and then use the redshift to calculate the velocity. And then they graph those two values and estimate the slope, and then to calculate Hubble's constant, and to come to the conclusion that the universe is expanding and things that are further away are moving faster. in support of the Big Bang. Together with the same collaborators, we also developed a resource on the life cycle of stars, and which focus with a special focus on when different elements are synthesized through nucleosynthesis during their lifetime. Next slide, please. Okay, so this is a the first in several resources that we have that addresses information transfer and communications. And obviously this one is resolution. And students get to consider the benefits and drawbacks of the highest resolution images, and both from a science perspective and a personal perspective. Next slide, please. Okay. I'm just going to skip through these because I took too long, but please check out the Waves collection at 6.8 because I think a lot of these things would be useful also for physics teachers. This one in particular can be used to complement or perhaps in lieu of the ubiquitous Slinky activity when you're doing waves. Next slide, please. Oh. And I'm going to turn it over to Sean now. So next slide, please. So now the other Sean is going to give a more complete story about how he uses some of these resources.
Thank you, Sean. So if you're anything like me, when you read an NGS standards such as apply scientific reasoning and evidence from ancient Earth materials, meteorites, and other planetary surfaces to construct an account of the Earth's formation and early history, you have no idea where to even begin or where to start with that. And, you know, I thought about it for a while. I was like, all right, so what's the guiding question here? And I came up with, what we want to look at is how old is the Earth? So let's start there. So it kind of had to think of where can I find resources that'll explain how old the Earth is, it'll engage students, that'll get them to think about this more and still apply the standard here. Well, I realized the better question we have to ask, and the one that you can't just Google, because as soon as you throw how or why in, the Google machine kind of breaks down. So ask the question, how do we know how old the Earth is? And so that's what then led me to this resource that I use about the formation of the moon and the age of the Earth. So the more that students can use data to support their claims, the better. So this allows us to be able to look at hard evidence and support that. So I found that claims evidence and reasoning is very useful, and the more we can get students to do it, the better. Next slide, thank you. So hopefully you can see the resource looping through there. It's essentially kind of like a Google slide and a PDF article were merged together with a couple of videos sprinkled in. And it's nice because you can zoom in on all the resources if you need to as well to get a better look at, you know, a little higher resolution as we were just looking at right there. Some of the topics that are covered is the age of the Earth. So if you're looking to talk about how old the Earth is, how we know this, to look at the chemical composition of it, the formation of the moon. So I like to spend at least a day or two on the formation of the moon and talk about the theories of what created it and how we know, or how we've come to these conclusions. It also covers NASA missions. I think it's important that we always focus on the fact that science is coming from humans, that there are people who came up with these ideas that led us to these conclusions. So how did they get there? What did they teach us? I do think it's very important if we look at a lot of these NASA missions. I've always found it's really helpful to look at things, using the movie Hidden Figures is great if you can throw that in as well. And it also allows you to analyze a lot of data. And so it's really helpful that students get to actually go in there and look at different data sets and go through that in order to see how we came across these conclusions. Next slide, please. So how do I use this resource specifically? I came up with a Google Doc. And Carolyn, there we go. So you can see right there. So this is just a Google Doc that I share with the students. I actually color code some of the questions. So the gray boxes there are the short answer ones. So there's some information they can copy and paste directly from the resource. And then there's others that I want them to spend more time thinking about. And that's what the blue box is. And you can see there, those blue box questions, those are the ones that I want the students to spend some time thinking about. So it comes with textual analysis questions. So they're going to read through the different slides and figure out what is contained in there. So you're looking at the big picture, now distill it down into a few words of your own, because I found that students struggle a little bit with paraphrasing, kind of putting things into their own words. This is a great way to give them something that's not too dense in order to work on that. It also gives them short answer questions. So if you're a bio teacher, then especially if you're in PA, then you know what the keystones are. At least you know about standardized testing, where the more we can get them to work on their short answer questions, the more we can get our students to generate these answers and to think about these, I find the better. So at least we give them a chance in order to work on their short answer question writing. And again, it gives you additional evidence-based inferences to draw from. So we allow the students to look at the evidence provided to them, draw their own conclusions from it. My favorite thing to do there, and I think it's the last one on there, I like to ask the students, do you have your own theory of how the moon was formed? And I get some very interesting answers from that. And sometimes every now and then you find a couple of students who really get the question and go into that detail. You really get to see the wheels are spinning and there's a lot of contact being made. You know, a couple kids will just say no. It's like, all right, well, I tried, but you know, I can do what I can do. Next slide, please. And things that are reinforced with this. So as a earth science teacher, I'm sure you find that rocks and minerals are really hard to get to come back to. You know, you cover it and then every now and then you ask yourself, how do I reinforce this? How does this come back? How do I use this again? So this is a great way right there. You can see there's an example of how rocks and minerals are used in order to show us how old the moon is, which also then directly ties in with radiometric dating. So that's helpful to reinforce that idea, because sometimes students kind of struggle with this idea of absolute and relative dating. And so this shows you an instance of using radiometric dating to support a claim. Density is also in there. So that's a great lab to start the year with, I always found, you know, or at least with the minerals, you drop a little mineral in, figure out what its density is. So I think that's a fun one. And it's really good. Again, just come back to it again and again, and then they're going to remember it. I covered the periodic table just a little bit, but I think it's important to give them as much as we can of chemistry beforehand. I know it's very useful when it comes time for the bio keystones here in Pennsylvania. But, you know, to actually know what's on the periodic table is super helpful. Actually, at school, I have a giant periodic table behind me. So you see it all the time whenever I'm teaching in the building remotely. So, you know, I think that's great for them to see. But I do think this is a great resource that allows you to see a lot of evidence all in one little spot. So it's not something where you're not circumventing the entire internet looking for this. It's condensed down to nice 12 little slides that you and the students can go through kind of at your own pace. And again, with the Google Doc that I use, it allows you to kind of pick and choose how you want to use it. So if you think there's some information that's a little over their head, you don't have to include that part. There's a couple of slides I shy away from because I don't know how well some of my students would do with that. Now you could add those back in and personalize it for your own. So, you know, this is a resource where it's kind of a cafeteria choice. Like, yeah, there's 12 slides. You don't have to use all 12 slides. I do want to thank the BUAC for this resource. I think it's great. This is the Moon Formation and Earth resource. The link was on there, and I do believe it'll probably be in the chat here as well. So I highly suggest you check it out. I'm going to turn the mic over to Eric.
Right. Thank you, Sean. So my resource is the Ocean and Climate Heat Distribution, which is an entire lesson plan. It includes a ton of media as well as its own interactive lesson component. So I'm going to kind of walk through some of these things. And it was brought up earlier, but one of the best pro tips that I got actually at a conference from Sean Stevens was that a lot of the very useful media lives in different grade bands. And instead of telling your students that this is like helping you out, and it's really for third graders. You can just show them the video and you can pull a lot of the stuff down. For some of the personal story, when we were doing in-person classes, this is what I would do at my school because we didn't have great internet all the time, is I would download most of the resources ahead of time, and then I would have them on. And you see the arrow there to the you may also like. It's just talking about heat on Earth, and maybe I need to go back over like the Earth tilting and kind of show how that helps out so the kids have that. That they should have gotten years ago, but it might come up. So I did pull down a ton of different things offline so that I could play them if it came up. And they're just great videos all around. I mean, they're from NASA and NOVA. And I'm going to be talking about all of this, but on the next slide, we're just going to have, this is what I like to start my class with. Oh. Did the GIF not work that time?
It'll work. Yeah, just give me a second here. Let's go back.
Yeah.
Here we go.
This is something that I would put in as a little bit of a kind of just quiet thing on my projector as students were coming in. Because we couldn't play the video in the slides easily, this is a short GIF that I made of it. But I like to just have it without commentary, without any bell work that has to deal with it. The real video is a couple minutes long, so I would keep it playing as the students are filing into class. And it gives them something to look at and to really start kind of doing the covert work of learning and creating some of the questions in their own heads. My students in particular are from the desert Southwest, and a lot of these things like ocean gyres, they have no idea about. And if we do talk about like the old ocean conveyor belt, nomenclature doesn't really do it justice when you can see this. And we all have experience and we know that these are, you know, vector lines. And so we're seeing speed and relative amounts of force that are going on. But my kids are just looking at this and I've gotten questions from them all across the board. My favorite is somebody asked if this was like that Van Gogh painting. Because as soon as it was asked, I was like, oh yeah, that's exactly like that. But no, not at all. But can we get the next slide, please? So working on integrating the digital media into my classroom, I really do use it to act as an anchoring phenomenon for a lot of the continuity from class to class, because the kids do a lot of the heavy lifting coming up with questions. If I can just show them these kinds of charts and visuals, these are really outside of all my kids' life experiences. So having something that makes it real does help out just tremendously for me to make my job easier. And one of the things that I've always said about the project is that it works best with these ideas that are too large to effectively model. I used to have a thing in class to model convection where we'd put a candle into an old fish tank and you'd have like some ice on one side. And when you snuff the candle out, you could see the smoke circulate, except it didn't work very well. And this really brings it together a lot better. It's also using different images to get at the whole story. So we have, for this, it's about density and ocean circulation. So the first thing is uneven heating, and you can see that right there. It also brings in salinity. There's something going on in the Mediterranean with that the kids always can visually notice and then start asking questions about. And there's also the wind action and some of the wind vectors. I didn't include them because we didn't have time, but they are just gorgeous to look at. And then we hear a lot about 3D science practices, but this is also like thinking in 3 dimensions, because the water diving down is just, it's mind blowing for them. And we have some visuals where it takes you under the water to see what the difference is. And so it really brings in that third dimension. Next slide, please. And there are plenty of supports. There's language assistance that helps with just vocabulary work. In case somebody needs the extra help, you can print them up ahead of time, which I have done. There's also a lot of things are now in Spanish, and I actually was one of the pilot classrooms for this. So I've been using it for years now. And as I come back, new things are showing up. The Spanish language in its entirety was new after I had first run it, and now the non-visual supports are there also. But what I really like is just in the interactive lesson, there's different ways for the students to show understanding. So there are kind of the short answer and the essay questions that are built into it. But you can see this is over the shoulder of one of my students who was supposed to be circling, where they saw this is different densities of water, I believe, and they had to circle where they saw the differences going on. And it gives them that tactile information, as well as kind of looking at it and wondering what is going on with some of these different things. And just the ton of other things. I know I said always check the you may also like, but those media galleries, they have so much that you can bring in. Being stuck online, it has been a lifesaver to be able to stick them all in. But I can't stress enough how useful they are, I mean, back in person as well as now. But that's what I have to say, and I'm turning it over to Carolyn.
Great, and thank you so much, Eric and Sean and Sean. The images are just gorgeous, and I think we've all made the point that the project continues to publish resources on PBS LearningMedia. Most of what you saw tonight is very new. More is coming, so please check back often. So we are winding down right now. I just wanted to remind you that the go-to site for everything you saw tonight, plus thousands of other resources, is the free site, pbslearningmedia.org. You're welcome to browse the site without signing in, but we encourage you to sign in so that you can make full use of the site, download resources, save things to folders, assign things to your students, etc. So the collection of Bringing the Universe is under this beautiful banner on the site, but there are, as I mentioned, many, many other resources, and many resources organized under other banners of collections. So a collection is a curated group of resources that you can access through one URL. So Nova Wonders and Nova, of course, GBH Production is represented on the site, hundreds of resources drawn from Nova. Making North America, HTO, the Molecule That Made Us, was a recent broadcast on public television, and we have resources from that, and the program Nature. So just a couple of examples for you to just think about the possibilities and go to the site and explore on your own. I mentioned that this is the last in a series of 4 webinars, grade specific. The links to the others are here on the slides. We are sharing the slides with you. We are sharing a resource document that includes all of the links of what you saw tonight, as well as the survey link. And is there anything else on that? I think that that's it. And then coming up, the end of the month, we have a mini series of 2 webinars that will address strategies for supporting EL students in science, drawing on some of the resources in the collection. We'll have 2 teachers in each of those webinars, as long as our in-house science expert, Sean Stevens, and she'll be leading those. Grades K-5 on March 23rd and grades 6-12 on March 25th. And you'll get registration information for those. This is the survey link that I mentioned, very quick. It really helps us. Our research department gives us the results, and we do carefully take it in and try and make changes, and we're always evolving and trying to do better. And you may download a certificate of acknowledgement of your participation tonight at the end of the survey. We're very active on social media. We encourage you to follow us or repost what we do. And I want to thank you for your time and for all that you do. And thank you to the presenters, Angelica, who's been in the chat. This is my contact information, Carolyn_Jacobs@wgbh.org. You are welcome to email me with any questions or comments or suggestions. And I think we are ending right on time, or maybe up exactly on time. Okay, so if you did post things in the chat that need more of a response than we were able to give you live, we will get back to you individually. I want to thank everybody again. We'll keep the chat room open for another minute or so and wish you a wonderful rest of the evening. And good luck with all of you for the rest of the school year. Stay healthy, everybody. Thank you.